Hello people and welcome back to another video. In this video, we'll be continuing from where we left last time in the last session. So in the last session, we discussed the idea of test statistic. We understood the concept of test of significance, and we went over a general idea of how do we go about solving a problem of hypothesis testing when we have the data. How can we calculate the test statistic and solve a problem of hypothesis testing? Now, in the previous session, we went over a general idea, but in this session, I want to solve two problems with you, and these numerical problems will make the idea, the concept, and the general procedure a bit more lucid. So, if you have watched the previous session, please go ahead and watch this session. The idea of hypothesis testing and test of significance will be clearer to you. And if you haven't watched the previous session, I would request all of you all to watch the previous session and then come to this session where I'm discussing the problems. So this is what we discussed in the previous session. Let me go ahead and remove this. Alrighty, we are all set to go. So the first question reads, a gym is interested in whether a 6-week weight loss training program they launched has been successful in helping their clients lose weight. To assess this, they took a sample of 30 participants. Your null hypothesis and alternative hypothesis are given. This is an example that we saw when we were discussing how to actually go ahead and formulate the null and alternative hypothesis. Here, as you see, this is a one-sided alternative hypothesis test where we are only worried about collecting evidence against the null hypothesis in only one specific scenario where the mu has to be less than mu naught, where mu naught is the population mean at null hypothesis. Here mu naught is 0. We have been also given the population standard deviation. We have been given the sample mean of the participants as well, and we have been given the number of participants. Let us write down all these values. Value of sample mean is given as minus 2.98. Number of participants is equal to 30. And my standard deviation is 6. And my mu naught is equal to 0. If I have to calculate my z statistic, it will be x bar minus mu upon sigma divided by square root of n. Minus 2.98 6 upon root 30. I'll pull up R, and using R I'll calculate my z value. So this is another benefit of the R console, is it can be used as a calculator. So we have minus 2.98. You divide that by 6 divided by SQRT, which is square root of 30. You get the Z value as minus 2.72. So this Z value is coming out to be minus 2.72. Now, This is the value of my Z statistic. Now, from my Z statistic, how will I calculate my P value? We discussed last time that if this is my Z value and I have to figure out my P value from the Z value, then P value is nothing but probability of my Z value being less than mod of Z. Now this is because here we are concerned only with the one one-sided alternative hypothesis where we need to find evidence of mu less than mu naught or mu less than 0. So we are concerned about this shaded area. My central value is at 0 and I have been given a point Z and I need to calculate the area towards the left of my Z value. So if you remember when we were discussing normal distribution using R, we went over this concept that whenever we are given a point and we need to calculate the area to the left hand side, the R function that we use is P norm. And because the central value is at 0, this problem is of standard normal distribution. Here we will put the Z value, which is minus 2.72. And here we can just put Z. It will automatically give you the P value or the probability value. So the probability value is, or the P value is 0.0032. So your P value, sorry, the P value for this problem is coming out to be 0.0032. Also, I want to elucidate one more property over here. I want to tell you guys about, or I should say, I want to reiterate about the symmetric property of normal distribution curves. So this is minus Z. If this is minus Z, then this will be plus Z. If the area towards the left of minus Z is 0.0032, then what will be the area towards the right of plus Z? Let's calculate that. So if I have to calculate the area towards the right of plus Z, then I'll be taking 1 minus P norm of 2.72. Let's take 2.72 self. As you can see, the value comes exactly the same, which is 0.0032. So what does this tell us? A, it reiterates the symmetric property of standard normal distribution. And more than that, it tells you about how do you calculate area when it comes to the different problems that you have on the basis of hypothesis testing. So this was my first problem. Let me move on to my second problem. Now, second problem introduces you how to solve questions on two-sided hypothesis testing. Let me go to the question. So normal levels of this chemical are 15 parts per million, Sample from 50 water sources throughout the county are taken and the levels of this chemical are measured. We have been given the null and alternative hypotheses. We have been given population standard deviation of 6.2. We have been given sample mean of 50, and we have been given 50 observations. So using CLT, also you can see above using central limit theorem, the distribution of sampling, the sampling distribution of means comes out to be normal distribution, which is why we can go ahead and apply the z-test. Now here in this case, we have been given the sample mean as 16.4, and you have been given the standard deviation as 6.2. We have been given n is equal to 50. First, we will calculate z value. Remember, mu naught this time is not 0, it is 15. What will my z value? 16.4 minus 15 divided by 6.2 by square root of 50. We'll go to R and we'll calculate this. We get the z value as 1.596. So now we have the z value as 1.596. When you again plot the normal distribution curve, your again central mean here is at 15, but we have transformed it. So for standard normal distribution, your mu will be 0. Your z value, and this is the corresponding minus z. As you know, standard normal distribution curves are symmetric on both sides. But because this is a two-sided test where we need to calculate probabilities both for z is greater than z and z is less than minus z, we are concerned with both of these areas. So P of z greater than or equal to z is same as probability of z is less than equal to minus z, which is why this necessary probability for this question will be twice of probability of z is greater than equal to z. Which is going to be twice into 1 minus p norm of z1. So your p value here is 0.11. So here you can see that the p-value compared to the last p-value is significantly higher. Now, we will always have a threshold to which we have to compare our p-value in order to finally accept or reject the null hypothesis. That value is called the alpha value or the significance value. We will discuss more on that in our next session, but I hope this session gave you an idea of how do you actually go ahead and calculate the test statistic and the p-value for a given problem of hypothesis testing. I hope you enjoyed this session. I'll meet all of you in the next session where we'll be going over the alpha value or the significance value and a few more problems on hypothesis testing. Thank you.